So welcome, and today we're going to look at Laplace transform of Laplace transform of t square sine 2t. So solution. We know that this one can be simply given by the Laplace transform. First, you recall that Laplace transform of sine at is equals to a divided by a squared plus a squared, and therefore, so that implies sine 2t is equivalent to 2 s squared plus 4. So with that in mind, again you need to use this formula that says that with this now, this simply implies that it is the second derivative. So again you need to recall that the Laplace transform of t to the power of n f of t is simply -1 to the power of n ds of f of t, and therefore in this case we are having a Laplace transform of t squared sine 2t, and this simply implies that it is, if we apply this formula, this is -1 to the second power multiplied by second derivative with respect to ds of f of t. Now the f of t here becomes sine 2t, which is given by this. So this is 2s squared plus 4 then from there it simply implies that we differentiate the function, and we can simply say that this is d of ds into d of ds of 2 over s squared plus 4, and with that this is equivalent to d of ds into 2 into s squared plus 4 everything to the power of -1, and from that we can simply indicate that if we differentiate what is inside this bracket, this is d of ds into -2 into s squared plus 4, you subtract 2, -2 multiplied by 2s, and this will give d of ds, which is -4s. You divide by s square, this is s square plus 4, close the bracket, everything squared, and therefore it implies that we differentiate this function again. So differentiate again, and upon differentiating this by use of quotient rule, we hold 4 minus 4s constant multiplied by d of ds into s squared plus 4 squared. You subtract, you hold the denominator constant. This is s squared plus 4 squared multiplied by d of ds multiplied by negative 4s, or 4s, sorry. Then the denominator becomes s plus 4 into, this is into power 4, sorry, but we can put it as s plus 4 into the bracket, then into bracket s plus 4 cubed, such that if you multiply the two, it gives to power 4. Now with that, let's perform our derivatives. So this is minus 4s into 2 multiplied by s squared plus 4 multiplied by 2s plus, you have negative, and this negative just becomes plus 4 into s squared plus 4, everything squared. You divide by s squared plus 4 into s plus 4 cubed. So upon simplification, we have 2 and another 2s here, and there's this negative 4s. So this will simply become minus 16s squared into s squared plus 4 plus 4 into s squared plus 4, everything squared. You divide by s squared plus 4, divided by s squared plus 4. And from this one, here we have s squared plus 4 cubed. Sorry, I was setting up my microphone. Then you can simply simplify. This part will cancel with this part, and therefore we are left with minus 16s squared plus 4 into s squared plus 4, everything divided by s squared plus 4 cubed. So if we collect the like terms on the numerator part, this is minus 16s squared plus 4s squared plus 16. divide everything by s squared plus 4 cubed. So we can simply say that Laplace transform of t square sine 2t is equivalent to minus 12 s square plus this is plus 16 divided by s square plus 4 cubed, and that is the final answer.